like this, where we did x plus 2 times 2x plus 3. And what did we do with stuff like that? FOIL. Thank you, Sam. Didn't we FOIL that? It's a binomial times a binomial. Okay. So in chapter 5, we came up with 2x squared plus 7x plus 6, right? And that was good, right? So if you did that on a quiz or a test, then hey, full credit, we're all happy. In chapter 6, here's what we're going to be doing. We're going to be starting with this and asking ourselves, okay, there's a polynomial right there. What times what would give me that polynomial? So we're going to try to break it back apart and turn it back into the factors that would have gotten it there. That make sense? So we are simply going to take chapter 5 and reverse it, more or less. Okay? So let's go ahead and move past where we had our video, our intro video. So the intro video was through the first couple of pieces of 6.1. And so this was all the intro video. And I do want to talk real quickly about the question on the intro video. Let's see here. If I remember correctly, the question on the intro video was this. It was, let's just lose that. Thanks. Sorry, it's like the 4th time that's been in the video, and I'm not a fan of that. Factor, wasn't it like 8b squared plus 48b? Yeah. Does that sound about right?
The square was on the square was on the 48b.
Oh, it was on the second one?
Yeah. No, was it? Never mind.
Well, you know what? To be honest with you, whether it was or wasn't, we can still illustrate the same point. So looking at that right there, is that a binomial, a trinomial, a monomial, or no special name?
Binomial. Yeah.
Binomial, right?
Yes.
If you're looking at my face, you're looking at the wrong thing.
Okay.
And you're still looking at my face. You should be looking up there.
Okay.
There we go. So 8b squared plus 48b. In the video, I think it said factor, I think specifically it said factor the GCF, the greatest common factor. The number one wrong answer on this was 8 parentheses b squared plus 6b. That was, of the folks that missed this one, that was the number one wrong answer. And I want to say that you haven't actually written anything incorrect. You just haven't factored out the entire GCF. Looking at those two terms in there, do you all see how there's a factor of b in both terms? Right? Basically, there's another factor of b that could be undistributed. And so if I undistribute the whole thing, if I had a b squared before, but I took out one of the b's, what's left over? A b. And for the other term, I had a 6b, and I took the b out. I undistributed it. Isn't the 6 the only thing that's left over? So that was from the video, and that was the correct answer there. Kendall, your question.
So is there any way that you can redo the question when it's wrong?
No. So the question is a check for understanding. So it's simply me looking at the video and saying, okay, up to this point we've covered factoring out a GCF, and I want to see, do they understand it now?
Okay.
Does that make sense?
Yeah.
So, so I would, so you get one shot because I just want to see, did they understand?
Okay.
That makes sense?
Yeah.
Especially with a multiple choice, if I give you 3 or 4 shots, you better get it right, right?
I was going to say that.
It kind of defeats the purpose, right?
I watched it 5 times and I
Yeah.
can't redo it.
I don't think it gives you chances to retry.
It doesn't. But I was just, okay.
So for that reason. Okay, so let's move forward and let's try some examples here that are further ahead in the notes. So take a look at number 3. It says, find the greatest common factor of 18y squared and 45y. So this is kind of right out of the video, 18y squared and 45y. We're going to try to just decide what the greatest common factor is between those two. Do you remember how to do this from the video?
Yeah.
Factor trees. So give it a shot, see if you can do a factor tree with these and figure out what the greatest common factor is. I'm just really sorry about that storm cloud there on the screen. They told me they're going to get me a new bulb or a new projector. You see how the top is really dark?
Is it the light?
No, it's the bulb or the projector. They've been up here fooling around with it. That's why it's been moved. But they're working on it. Okay, you're working on number 3. So the way we do this is we do a factor ladder. 18 is 2 times 9, and 9 is 3 times 3. So we could say then that 18 y squared is 2 times 3 times 3 times y times y. Is making sense? It's making sense? Okay. And then 45 is, do you guys do 9 times 5? I think that's the most obvious one.
15 times 3.
15 times 3 is another good one. Yep.
That's not a good one.
No, it is a good one. They're all good. Doesn't matter at all.
They all work if they equal 45.
They do.
Okay, great.
Quiet down, guys. Hey,
You're welcome for helping me out.
guys are getting distracted by stuff that doesn't matter. Okay. All right, so then 45y is 3 times 3 times y. So notice it says greatest common factor. We're looking for the stuff that's in common, right? The factors in common. And so what I'm looking at here is I see that they both have a factor of 3, and they both have another factor of 3, and they both have a factor of y. We'll finish this up in a second.
Why didn't you put the 5?
Oh, sorry.
Yeah,
My bad. I forgot it. Let's put it in there.
wait, is that a 0 and 2?
That's a 2.
Z what? Where's the Z? Oh.
There's no z's involved. Sorry, I just forgot the fun. So,
That's true.
bless you. What's in common here? What's in common here are a 3 times a 3 and a y, which means that the greatest common factor is 9y.
That's why you did it with the factor tree, because I was really confused on how you did it, because I thought you did 3 times 3 times 3 times 3.
Ah, we're just looking for what's in common. There's one pair of 3s, another pair of 3s,
Just do 3
and a pair of
times
Ys.
3 and- Okay.
One can
Hey, Grace, you know what causes confusion is just outbursts, especially with stuff like that going on. Go ahead.
I'm really confused. Why are you? What? Why did you do the y to the y that's far away from it instead of the y to the y that's above and below it?
I could have. So Grace, if I did this, I still have one common y, right?
Oh, okay.
It makes no difference.
Yeah.
If I decide to go diagonal or vertical, it's still just a common y.
Okay, I just didn't know if there's like.
Nope. Any other questions?
Yes.
Jake?
So does the other pair of 3s come into play?
What do you mean the other pair?
Like, so I see that you have 2 pairs of 3s.
Yep, so there's one pair here, there's another pair there.
So you don't necessarily take like,
You think of a pair of 3s as just a common 3.
okay.
So just one.
And then the other pair of 3s as another common 3. So this pair of 3s is that one.
Okay.
This pair of 3s is that one.
And then the y. Okay, thank you.
Yep. Other questions? Okay, so there's only one other example in our notes here. And we took a lot of time with your tests, so we're going to be able to do this one for sure. And if we can do one more, maybe we'll go to the board, or maybe we'll just stay at your seats and do one more. I don't know. Certainly you can see that I intended it for us to go to the board. Check out number 4. I think I'd like to do this one here with you. And since we're definitely not going to get a ton of practice at the board this afternoon, we'll definitely open up tomorrow with some practice on this. So this says factor out the GCF. So there's a lot of ways you can do this, and I can break this down really small for you. We can leave it pretty kind of like a broad view as well. So let me try both ways and see if I can help you understand. The one thing you're going to want to do, the one thing you're going to have to do is you're going to want to practice this. This is I would put number 4 in the category of one of the more difficult ones, I would say. So if you can start to understand with number 4, when you look at simpler ones and maybe equivalent ones on your WebAssign, hopefully you've got a good shot. I'm making a video here so you can go back and watch this. So here's one way of looking at this. Can you all see that there, with the two different terms there is a numerical base associated with both of them? Can you see that?
Yeah.
There's a 30 and there's a 45. So I want to ask you guys this question. This is like the bigger, quicker way of doing this. Can you guys think of what is the biggest number that goes into both 30 and 45? 15. Doesn't 15 go into 30?
Yeah, twice.
And 15 goes into 45?
Yeah.
3 times.
Once you go above that, it's not going to go evenly into one of the two of them, right? So 15 is the biggest number that goes into both 30 and 45. That's going to be the first part of my GCF. So I'm going to write that over here. Now, take a look at the M's. So in the first term, I've got m to the third, and in the second term, I've got m to the fourth. I want you to listen really carefully to this question. Just listen carefully. If the first term is m to the third, the second term is m to the fourth, what do the two terms have in common?
Nothing.
No, they definitely have something in common. That's not enough.
M3, M2, I'm sorry.
M to the third is what's in common. Wouldn't it be fair to say,
Wait, but it's
okay, okay, I hear your questions. You're saying, hey, but one's m to the third, the other one's m to the fourth. Let's expand what this means. I wasn't gonna do it this way, but I think this will maybe help you. Let me give myself a little more room.
They're both 1M.
Shh. Just listen. So, couldn't I write this? This is the slow way. Couldn't I write m cubed like that?
Yes.
Yeah.
And couldn't I write n squared like this?
Yes.
Yeah.
And then m to the fourth is really m times m times m times m. And then I got one more little n right there.
Yeah.
So you guys have already decided that the common factor, the greatest common factor between 30 and 45 is 15. So we've written that here. Now look at the m's. There are 3 of them here. There are 4 of them there. So what do both terms have?
3 M's.
Don't they both have 3 of them?
Yes.
Isn't it fair to say that the second one has an extra one?
Yes.
But they both have 3 of them.
Yes.
Okay, so that means the greatest common factor, at least with the m's, would be m cubed,
M2.
m to the third. Now look at the n's. The first one has 2, and the second one has 1. It kind of got cut off there.
Can only have 1.
So what's in common?
1.
One of them, right? One of them has an extra, but they both have 1. Both have at least 1. And so the last part of your GCF would be n. So 15m cubed n, that's your GCF. Now we got to write what's left over, like what would lead us back to the distributive property. What's always associated with the distributive property?
Parentheses.
Always parentheses, right? In fact, sometimes we abuse the distributive property, like whenever we see parentheses, but you're always going to see those with the distributive property. So here's the process for writing what's left over. We always want to write the leftovers in these scenarios. Originally I had a 30, but didn't I factor out a 15?
Yeah.
That's the GCF. If I factor a 15 out of a 30, what do I have left over? You're tempted to say 15, right? Because
No, it's
30
5
minus
to
15
3.
is
It's 5 to 3, right?
5 to the 3?
5 times 3 is 15.
Yeah. So if I had a 30 and I factored out a 15, what's left over? 2. 30 divided by 15,
Yeah.
right? So 2 is left over. Now in that first term, I had 3 m's, and didn't I factor out 3 m's?
Yeah.
So how many are left over?
1.
If I had 3
0.
and I factored 3, there's no more m's left, right? They're all gone. So I'm not going to write any m's in there anymore. But I had 2 n's, and how many did I factor out?
1.
So how many are left over?
1.
2n. Now see if we can get this second one. If I had a 45 for a base, and I factored out a 15, Paige, what's left over?
A 3.
A 3, because 45 divided by 15 is... So I think what you're confused about, some of you, I think you're trying to subtract 45 minus 15. Remember that when you reverse the distributive property, you're actually doing division. it's really 45 divided by 15. So the leftover is 3.
Then there should be one M, right?
And let's do the m's. How many m's were there to begin with?
4,
Or
And how many did we take out?
3,
How many are left over?
1.
1. So m.
Okay, so it's close.
And how many n's were in there to begin with?
0 or 1.
There were, no, I'm talking about the second term now. The second term only had the 1n. So if there was 1n and I factored out 1n, how many n's are left over? None of them, so I'm not going to write anything for that. This right here would be a complete factoring of this. I factored out the GCF. I want you to hear this really clearly in our final seconds here because I need to let you guys go. Any thoughts on how you could check your answer?
multiply.
Do the distributive property. I should be able to do the distributive property and get what I started with, right? It should, if you did it right, it should work, okay?
That makes more sense now. I was wondering what the minus sign was.
It's just separating the two different terms. Yep. Hey, have a great day. Don't forget to print out your notes for Wednesday.